Hello, my name is Dr. Halkarma Misupova, and I'm here to present a very short talk about what are antibiotics and how do they work. The objectives of the talk would be general structure of a bacterium, what parts of bacteria can be targeted, what are antibiotics and how do they work, and combined medications against resistant bacteria. Let's look at the structure, a general structure of a bacteria. Bacteria are single cellular organisms, and they are classified as prokaryotic as they do not possess membrane-bound organelles. Their DNA forms one single chromosome, but they also contain a plasmid, small loop of DNA containing genes. On the picture you can see cellular wall, cellular membrane, DNA plasmid, ribosome, cytoplasm, and flagella and pili. So antibiotics can target cell membrane. They can also target cell wall. They can inhibit RNA and DNA synthesis. Additionally, antibiotics can target ribosomes and protein synthesis and also inhibit folic acid metabolism. So what is an antibiotic? It's a natural or synthetic compound that can inhibit the growth of bacteria, and that property is called bacteriostatic, or actively kills the bacteria, and that property is called bactericidal. Bactericidal or bacteriostatic characteristics sometimes may depend on a dose of a drug. Bactericidal agents are mostly preferred and in conditions such as endocarditis, meningitis, osteomyelitis, or neutropenia, in particular due to the seriousness of the disease. Antibiotics can be classified based on the mechanisms of their actions. So we already mentioned types of antibiotics, and we can follow further. They can inhibit cell wall synthesis of function, and they are beta-lactams, penicillins, cephalosporins, carbapenems, and monobactams belong to beta-lactams. They also have vancomycin, daptomycin, and polypeptides. Antibiotics can inhibit nucleic acid synthesis of function, and these are quinolones. They inhibit DNA gyrase or topoisomerase 4 enzyme. They also inhibit folate synthesis, and these are trimethoprim, sulfamethoxazole. They can also create free radicals, and these types of medications are metronidazole and nitrofurantoin. Antibiotics can inhibit protein synthesis. In particular, 50S subunit of ribosomes. The examples would be macrolides, clindamycin, linezolid, streptogramins, and chloramphenicol. And they can also inhibit 30S subunit of ribosomes, and these are aminoglycosides, tetracyclines, and tigacyclines. Let's look at the mechanism of action of penicillin. In the top left picture, you see a cell wall of a gram-positive bacteria, and there is an enzyme called penicillin binding protein. It's an enzyme that assists in creating the matrix by cross-linking the chains to form the cell wall. And penicillin can bind to this enzyme and block this enzyme, and thus destroying the cell wall or the construction of a cell wall. Some bacteria can express beta-lactamase. Beta-lactamase breaks the beta-lactam ring of the antibiotics, making the antibiotic ineffective. So beta-lactamases can leave beta-lactam ring of penicillins and make the antibiotic inactive. Some penicillins are combined with beta-lactamase inhibitors to be more effective against beta-lactamases and penicillin binding proteins. It is important to know the classification of bacteria and their susceptibility to classes of antibiotics in order to successfully treat bacterial infections. And some examples of penicillins combined with beta-lactamase inhibitors would be augmentin, unicin, and zoysin. Thank you.